Welcome back to another exciting day in the land of algebra with Mrs. Bremser. Today we are finally going to put some of our exponent rules to use. The first thing I would like you to do is to write down these 4 problems on your warm-up on the top of your notes. Pause the video, go ahead and simplify the 4 expressions, and then once you have your answers, hit play again and check to see how you did. So how did you do? On number 1, did you multiply the coefficients, which are 1 times 3 and get 3, and then did you add your exponents to get 7? On number 2, you should have divided the coefficients. 8 divided by 4 is 2, and then you would subtract your exponents. 10 minus 6 is 4, so 2a to the 4th. Number 3 is just like number 1. Multiply your coefficients to get 70. Add your exponents to get 7. Number 4 was just like number 2. Divide your coefficients. 27 divided by 9 is 3. And then when you subtract your y's, that would give you 7 minus 8 is negative 1. You will notice I sent the y downstairs to the denominator to make it a positive exponent, while the 3 is a whole number with a positive exponent of 1, so it stayed in the numerator. If you made any mistakes, please take the time now to correct them. Here is your objective for today. It is kind of long, however, we're looking at pretty basic vocabulary type problems today. 9.3, we are finally introducing ourselves to polynomials. The objectives you are writing is you will be able to define different types of polynomials, find the degree of a polynomial, find the number of terms of a polynomial, and write the polynomials in standard form. Pause if you need to complete writing your objectives. Some key vocabulary that we're going to need for this section. Number 1 is, what is a polynomial? A polynomial is an expression made with constants, variables, and positive integer exponents. For example, you will see I have 10t to the 6th plus 7t to the 5th plus 22t minus 4. There are 4 separate terms in that polynomial. Poly means many. There are many terms to it. When you look at what a term is, it is each part of the polynomial. They are separated by addition or subtraction signs. So for example, we have 1 term, 2 terms, 3 terms, 4 terms. That is a 4-term polynomial. Coefficients, we've been talking about that a lot. The coefficients are the numbers attached to the variables. 10 is a coefficient, 7 is a coefficient, and 22 is a coefficient. Negative 4 is not a coefficient. It is a constant. It is a plain number with no variable attached to it. So let's look at an example. Basic vocabulary here. When you look at 4x to the 3rd plus 2x squared minus 3x plus 1, can you identify what the 4 separate terms are? Are you able to see that 4x to the 3rd is a term? 2x squared is a term? Negative 3x is a term? And 1, or positive 1, is a term. When you look to see what the coefficients are you comfortable that the numbers attached to the variable are 4, 2, and negative 3? Those are coming from right here. Those are the numbers attached to the variables. Take a moment to make sure you can see the 4 separate terms and identify the 3 coefficients. Now we're going to look at some new key vocabulary. Monomial. Mono means 1. If we have 1 term, then it's called a monomial. 6.2, that's 1 term. X squared, 1 term. 3xy squared, 1 term. 2x is also a monomial. They are not separated or connected by any plus or minus signs. Now, a binomial has the prefix bi, which means 2. So we're looking at the sum or difference of two monomials. For example, 2x plus 3, you have two monomials, 2x and 3. 2x plus y, 2xy plus 3xy, those are two separate terms. My last example, xy squared is a term, negative 3xyz is also a term. So we need to now see the vocabulary that monomial means one, binomial means two terms. A trinomial, I'm going to guess you guys are good. Tri means 3. So that is the sum or difference of 3 monomials. You've got two examples I'd like to make sure you have in your notes. 8x squared plus 2x plus 3 and 4xy squared negative 2xyz positive 4. Both of those are examples of a trinomial. Now we're going to get to some more key vocabulary. Take your time to pause, write down the missing information on your notes, and then come back and listen to the conversation. If I ask you the degree of a polynomial, all I'm asking you is what is the highest power in that polynomial. So when you look at my first example, 10t to the 6th plus 7t to the 5th plus 22t minus 4. There are 3 exponents on the variables. There's a 6, a 5, and there's really a 1. If I ask for the degree, the highest power exponent is 6. So this would be a 6th degree polynomial. Yes, I would like you to write that example in your notes. Write that example in your notes and label it as 6th degree. If I ask you to write a polynomial in standard form, that means all your terms should be listed in descending order by degrees. What I mean by that is your exponents are going down in decreasing order. The exponents go from 6 to 5 to 4 to 3 to 2 to 1. You won't always have every degree represented, but they should be in order from greatest all the way down to least. The constant on the end, the minus 4, is always the last term. If I ask you to identify the leading coefficient, that is simply the first coefficient once it is in standard form. So the coefficient on the highest power is 12. So the leading coefficient in this example is 12. Take a moment to pause, make sure you have all those examples written down before you move on. Let's take a moment, look at an example. We have 2x squared plus 5x cubed plus 10. I would like you to pause, see if you can rewrite it in standard form, tell me the degree, the leading coefficient, and the total number of terms. After you've answered it, come back and check yourself. How did you do? Were you able to put it in standard form? 5x cubed plus 2x squared plus 10? Once you did that, did you see the highest degree, the highest power was 3? So it's a 3rd degree polynomial. The leading coefficient is 5 because that is the coefficient on the first term once it's in standard form. Did you also get the correct number of terms, 3? There were 3 terms, making it a trinomial. Take a moment, look at the next example, and see if you can answer the same questions. Pause, come back, and check yourself. How did you do? Did you get the correct standard form? The degree is 5th degree, leading coefficient -4, and there are 5 separate terms. If you made any mistakes, please take a moment and make your corrections now. Here's another example I'd like you to practice, basic vocabulary and applying it to your polynomial. Pause and come back and then check yourself. All right, how did you do?
When you rewrote it in standard form, did you come up with 4x to the fourth minus 2x squared minus 3x plus 8? That is a fourth degree polynomial because the highest exponent is 4. The leading coefficient is also 4, but that's because it's the largest coefficient. It's the coefficient in front of the term with the largest exponent. And interestingly enough, this is a 4-term polynomial. So all those answers were 4. How did you do? Make any changes you need to. Last example, and then we're done for today. Nice, easy, quick topic. Look at this example. Identify the standard form, degree, leading coefficient, and number of terms. Come back and check yourself. All right, for the final problem, how did you do? Were you able to put it in negative 7x to the fourth plus x to the third plus 9x squared plus x plus 2? That is a fourth degree polynomial because the largest exponent is a 4. The leading coefficient is negative 7 because it is the coefficient on the term with the biggest exponent. And did you see that it is 5 terms that make up that polynomial? That is it for today, ladies and gentlemen. You now have your opportunity to finish your notes, and tomorrow in class we will begin working on your 9.3 assignment. Thank you for listening.